What's up, guys? Back at it again. It's June 10th, 5 p.m. Yesterday was a very bad day. Today we bounce back. You know what I'm saying? Just the classic shite. Classing back at it again. Don't really want to do lectures today. Learned about pipelining. The next lecture is talking about exceptions and interruptions, which is pretty cool, I guess, but kind of don't want to tackle that right now. What I really want to do is get the labs done, so I can build my own processor. I feel like that's pretty fucking cool, actually. Um, Handling exceptions in I/O, exceptions and interruptions. I'm handling I/O as well. Um, I think the last lab will be just a full system integration. Right, the performance of MIPS. Full system integration, I think. Whole single cycle processor by assembly code that runs on FPGA board, yeah. Learn how the processor communicates with the outside world, yeah. Snake program, yep. Um, yeah, but the crawling snake is only it only shows up on the display. But I guess what I want to do would be more like actually playing a game, like through the VGA output, like onto a screen if I could. Um, that will be pretty cool, I feel. Um, and I think it is doable. Uh, Simple CPU programs. No, no, no. Simple CPU games. I forgot what it was called. Like there are two sliders, and then you have to move it to make sure the ball like bounces, and if it goes beyond, then you lose. Right? That's something that I want to do. Um, but I don't know. Let's just go through with these labs first. Right? Yeah, it is pretty cool though. But yeah, I am on lab 7. That's the one that I need to do. Um, Mars simulator to run your code. Don't know what Mars simulator exactly is. Once download, navigate it to the download folder. Compact data at address 0. Can I just use VS Code? Hmm. Yeah, okay, whatever. Um, I'll work on that after I do this. Yeah, I want to do um is implementing my own 32-bit single cycle processor on an FPGA board a good enough project to put on my resume, or is it too elementary? I am looking for software engineering roles. Mm, 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 mm. Mm, 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 mm. With pipelining, caching, or advanced optimizations. Senior level expectations. I think it's a pretty impressive project, if you ask me. Um, but whatever. Let's just do it first. Um, let's just do it first. Okay, combination sum two. Or do I want to do permutations? Combination sum or permutation? Let's do combination sum. All right, so what I did here was just basically walking down the tree, right? But the key thing here is this. Like recognizing how I'm walking the tree, right? Okay. Given a collection of candidate numbers, candidates, and target number, find all unique combination candidates where the candidate numbers sum to target. Each number in candidates may only be used once in the combination. Okay. I feel like it shouldn't be too different. Um, so there's vector, vector, and res. There's DFS, and it takes I, it takes target, it takes current, and it also takes candidates. I don't think, yeah. Here would be vector current, right? And then something here should be like this was the setup of last time, right? This was the setup of last time. Um, so in this case, each number in candidates may only be used once in the combination. Okay. Each candidate can only be used once. Okay, let's go to the drawing board. I feel like with these questions, like having the iPad really helps. Where's my iPad? Where is my iPad? Oh, I think it's outside. Give me a sec. Okay, so something to note is candidates, there can be duplicates, right? Um, but if there are two ones, then I can use one twice, right? Fine. Um, let's go to a random one. Okay. I want to share uh my iPad. Here we go. Okay. So let's think about this, right? Let's think about this. So I have 10, 1, 2, 7, 6, 1, 5, right? These are my candidates. And then let's say I start off at 10, right? Then this one next uh can be either including 10 or not include 10. And here I can't include 10 anymore, right? So it has to be I plus 1. So there's I equals to 0, I, and then I equals to 1, I equals to 2, right? Um, Target has to be 1, so it can't be empty, right? There's no way it's empty. Yeah. Um, then so it's include. So I think it's like it's kind of a mix between like the subset question and the combination sum question, right? I think each layer you have one. And because so left is include, right is exclude, right? And then left would be include, and then right would be exclude, right? Left would be include, right would be exclude. And then right, you see where I'm going with this? Include, exclude, include, exclude. Um, you see, and then it just goes. Um, okay. And that way, every single candidate will only be included once, right? I feel like that's pretty fair. Um, so what I want is if target equals to zero. Oh shoot, I have to come back here. Right. If target equals to zero, then res will push back current and it will return. Right? If target is this or I is bigger than candidate's dot size, then I will also return. Right? And in this case, what I want is current dot pushback. Um, I'll push back candidates I, right? And then I'll call into, so this is the case left, case where includes left side of the tree, right? And then there will be a case where excludes uh, right side of tree, right? So this would be I plus one, right? Target minus candidates I, right? Current candidates. And then the difference between this and combinational sum is that you're always calling on I plus one, right? Because you can only use it once. So according to this logic, um, so you start at 10, 10 is the root of the tree. Um, I think so. If we go back to the iPad, um, we go back to the iPad. So our logic right now is DFS. Wait, so current is a vector, and then DFS I plus one, right? Target minus nums I, and then current and nums, right? Whatever. So when I first call this, it will be DFS zero target empty and the candidates, right? Um, so this is the first call. And then current will become 10, which is on the left side, right? Which is on the left side of the tree, right here. And then um current becomes 10, target becomes, oh wait, t here is equals to, the test case is 8, right? Test case is 8. So what I have here, current is 10, um, and then 8 minus 10 is obviously too big, right? So all of these will be fucked off because this is already bigger than target. And then these are all non-negative numbers, right? So if I add them together, it's only going to get bigger. So anything past this node is automatically rejected. So this, it goes into the logic of imagine the second call. It will just return, right? Because it's negative. Because target is negative. So it returns. And then what happens is it pops current. So now it has nothing. So now I'm in here, right? And then it will call I plus one, which is one. And then target minus uh nums I. Wait, target minus nums. Oh, and then I should just call on target instead. Because if I call it on target minus nums I, that means when I call it into here, it will be target. It will be 8 minus 10, which is always going to be negative, right? So instead, I should call it on just target, so 8. So now I'm one level deeper, and then I'm calling one target, and then current has nothing, right? So now I'm in here, and then um target is not equals to 0, right? Target is still equals to 8, and then I'll call towards this side. Um, and then current will become 1. Um, and then, okay, I'm just going to erase all of this. So 1 and 2, 1, 2, nothing, right? And then it just keeps going. 1, 2, 7, 1 and 2, 1 and 7, 1, blah, 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 right? You get what I mean? So I think it's correct. I think it's correct. Let's come back to this. Let's just run the test case and see if it's correct. Maybe. Um, current pop back, sorry. Just that. No? Okay, what's going on? Oh, okay, now it's getting the duplicates. So it's no good. Um, why is it getting duplicates? 2, 5, and 2, 1, 5. Bum 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 bum. Bum 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 bum. I include Am I not only including everything once if I do this? So two, two, one, two, one, two, and two, one, two. Hmm. But they are the same. Hmm. Like they can be duplicated, but let's see. I can make it extra memory by pulling in a map. Like for example, if I do right for auto and candidates, um frequency n or plus plus, right? Something like that to track the frequency. And then if including some and not including some is the same as that including some and not including some. It has to be a combination of those, both those two things. How do you deal with the duplicates here? Like this one, you're giving a distinct integer, but now you have repeated integers. But you can use those integers multiple times. But when I use them multiple times, I still need them to be distinct, right? This is the tricky part. Um, How do I do it? If there are two twos, two ones like this, how do I get rid of some of the? Because when I traverse the tree, like one level could be one, and then two, and then one. Let's say it's one, two, one. Then I can exclude, and then I can flip them, exclude, include, right? Oh, yeah, get rid of that behavior. If I have to traverse the tree like this, there has to be a smarter way. I'm thinking if I push, before I push it in, I check for duplicates. That's the most simple, but I don't know if that's what they expect. I feel like there has to be a smarter way. Sort the input array and observe the recursive calls that are responsible for duplicate. Sort the input array and observe the recursive calls that are responsible for duplicate combinations. Okay, so if I don't do this, if I sort, right? So what if I sort the duplicate? So it's 1, 1, 2, 5, 6, 7, 10. 1, 1, 2, 5, 6, 7, 10. Then, okay, let's go back to the iPad. Say instead of this now, I have, what I have is 1, 1, 2, 5, 6, 7, and 10, right? So this would be 1, this would be nothing, this would be 1 and 1, this would be 1, this would be 1, this would be nothing. Let's just go with it first. 1, 1, 2, 1, 1, 2, 1, 2, 2, 2, and 1, 2, 1, 1, 1, 1, 2, yup, 1, 1, yup, 1, 2, yup, 1, yup, 1, 2, yup, 1, yup, 2. Okay, so it's these inner trees that are fucking up, right? Like these ones. Um, Dum 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 dum. Because this goes into here. This goes into here. And then this goes back to here. And this goes back to here. Which is already problematic, right? Which already creates a duplicate. So, so what are the problematic ones? This, this. Is there something to be found here? Like these two trees are literally the same trees, right? These two trees are going to be the same trees. And that's what's causing the problems, I feel. So out of these two trees, I just need to choose one tree, so if candidate 0 is equals to candidates 1, then I'll skip the right side, right? Does that work? Let me try. Let me try. So here, right? So if candidates I is not equals to candidates I plus 1, and then I go into this loop. If I is smaller than uh, candidates dot size minus 1, obviously. And No, that doesn't work. I have to get to the last stage. So here I already checked if I cannot be bigger than candidates dot size, right? So if I call, um, let's just run it and see if it makes sense. Yeah, there would be something here. I'm on the last stage. Like, let's say I equals to like 0, 1, 2, 3, 4, 5, 6, right? I equals to 6. Then this would not work. Uh, let's say if I is already equals to 1, and then I go if I is equals to I minus 1, then I return. Would that be fair? No, that would not be fair. Because then I miss both trees. In fact, I'll miss all of these trees, so that wouldn't work. So it has to be something that it's a condition that goes into a tree, right? What if I'm not doing on the right side, I'm doing on the left side? Like if I'm pretty sure this is right, but I have to figure out how to get rid of the overflow problem. Plus one. If it's the last case, go to the left. How do I make sure it doesn't go to the right? Right, okay, but this creates a problem. Yeah. How to merge these trees together. I really don't know. Honestly, I don't fucking know. Um, I assign candidates dot size. That is so insane smart. Oh my God, what the fuck? Why would this work then? Holy moly. Okay, let's go back to the drawing board. Um, I think I was pretty close. Um, I feel like I was. So if I'm here, I go to the left, I go to the left, I go to the left. And then, I'll just hella go to the left, right? And then when I come back, I'll go here because here I is not equals to I plus 1, right? So this continues. I'll come back here, and then do I go to the right? No, I don't. Um, because I equals to I plus 1, right? So I'll skip directly into the second stage. And then when I'm here, I will go through like this as well, I think. Yep, I'll go through this. And then when I return, I come back, and then this is equals to this, so I will therefore go directly into here. I want to see neat code explain this so I can fully understand.
Hey everyone, welcome back and let's write the problems to understand. And actually, there's another problem that will help you understand the trick behind this problem. It's actually an array problem. It's called threesome. That's also a part of the Neat Code 150 list. And it's
Done
beneficial
through
to
some.
know for this problem because we kind of eliminate duplicate solutions pretty much the same way once. Look at in the if. And then from here, we would have chosen from the next element, we can either include one, and then eventually we might get to seven, and then we might include seven as well. If we were to have skipped this one, we could have gone down this path. We could have included the seven, and then we could have included the one that came after it. And we would have ended up with duplicate combinations.
Yep.
So we want to avoid this case. And we can, believe it or not, still do so with two branch recursion. It's going to be similar to how we eliminate duplicates in threesome. So this is the trick behind eliminating duplicates. The issue here is that When we choose to include one or choose to skip one, we don't want to end up with another one on the same path where we decided to skip one. So how can we make it so that we never see another one again if we decided to skip it? Well, this is the trick. First, you take the input array and you sort it. So I'm going to redraw this in sorted order. Now it's sorted. Why did I put it in sorted order? Because I want all duplicate elements to be adjacent. It's not necessarily important that we go through the elements in sorted order. That's actually not important because all of these are going to be positive anyway. So they're always going to contribute to the target. We're never going to deal with negative numbers. So it doesn't matter so much the order that we go through them.
So I always want to skip one if I've already skipped one before. How does that make any sense? That's the insight, right?
Numbers, and we could reuse the same number an unlimited amount of time. So in the first problem, we had the input and we were able to solve it very simply with recursion. For a given element, either you include it from this including 10, we can have, it's going to be similar to how we do it. Well, this is the trick. First, be adjacent. So they're always going to contribute. Just not skip one. Well, if I shift it by one and it lands over here, I'm still able to choose from one, but I wanted to skip it all together. So this is where we're going to use something called a loop. I'm going to use a while loop, and what we're going to sit here and again inch recursion. So with this, I'll kind of run through the quick simulation here, and then we'll get into the code. The code is going to be very similar to combination, obviously over the target. At that point, we can aggregate everything. One, we could have chosen, I think it'll help you understand.
Do I get it? I've already skipped one. I can use it again, but then that will lead me to duplicates. So I'm going to take this branch, and then when I'm I'm gonna go to the next one. I don't want to take it because I want to skip it. So I'm gonna go directly to here. When I do take the branch, so these are all the branches that I will take, right? Which is fine. And then when I come back to one, I want to skip um this is what happens. I kind of get it, but kind of don't. Um, if you include it, you're already allowing it to be included.
Hey everyone, today we are going to focus on there's no more. There are ways to shifting, but in basically we use all number one by one and trying to find a unique combination. So yeah, so that is a one answer. And then at some point, we make a skip that loop because there's a possibility that we can make a same combination. So that's why we skip. And actually, we have another important condition. So if current number is greater than target, we combine candidates. So
Honestly, this one I don't really understand. Yo,
Yeah, Mudia, you are from Mama Hapana. Tua Moa Mama. Hoa Osaka.
I DFS I plus one target minus candidates. Current candidates. And then you'll want to pop it And then y plus 1 is here. Essentially call this. Fuck. What? Wait, what's wrong? I didn't sort it. I'm a dumbass. It's the whole point, right? You gotta sort it. Okay. Calling it there. Maybe doing some lab later. Yep. Peace.